Like, I had this idea in my mind that, like, computer science is full of, like, I don't want to say it, but, like, nerdy sweats. Hi, everyone. Welcome back to my channel. Today, I have a special guest, Arohee.
Hi.
Would you like to introduce yourself?
Can you go first?
Oh my god. My name is Suanna. I'm studying computer science and art at Carnegie Mellon, and I like to make art, and I code sometimes, but the art is more important to me.
That's good.
Yeah. Now it's your turn.
I'm Arohee. I'm a senior at CMU. I'm studying math with a concentration in discrete math, which means that, like, I do stuff that's, like, kind of at the intersection of, like, theoretical CS, math, and, like, I don't know, extra fun stuff that maybe I'll talk about later. And, like, when I'm not doing math, I like to watch video essays, listen to podcasts, I like to make jewelry, hand letter. Yeah, that's pretty much it.
Yeah, there's a lot of substance that we have to unpack in this video. Yeah, that's just the surface level description of Arohee. She's really awesome.
Thank you.
Yeah. So I guess we can get started.
Mm-hmm.
I guess, like, can you kind of go over, like, this autobiographical journey of, like, how you became, like, a math major? Because I know you weren't a math major when you first came into CMU.
This is a fun story. So when I started at CMU, I went in for chem. I think, like, in high school, like, my academic interest really mostly came from, like, what the adults in my life validated me for being good at. Which is, I think, typical of Silicon Valley culture. Oh
yeah, this is an important detail. We are both from San Jose, California.
We are.
Yay!
Which I think there's pros and cons to that, right?
Yeah, exactly.
Yeah, but I think that, like, when I came to CMU and I realized that, like, low-key everything is really hard, like, receiving academic validation, if that was, like, what my interests were predicated on, like, my interests no longer were my interests, and I think I realized that I just didn't really like chem, or, like, not to the point where, like, I wanted to pursue it as a career. So then I thought that maybe I should try out bio, because there wasn't really many real reasons to this. Like, I liked it in high school, and I did pretty well in it, but then I think I felt the same way about it. Like, it was interesting, but it just wasn't really for me, and then after my freshman fall, I, like, really considered, like, what if I just drop out of school? And, but I didn't, and then in the spring, I took a class called 15112, which is the intro programming class at CMU, and I thought that I would hate it or do very poorly in it, but turns out, like, it was not really like that. Like, I really enjoyed it, and, like, the more time that I spent, like, taking the course, I realized, like, okay, this is, like, something that I could see myself doing, and I think part of that was because, like, my recitation TAs when I took 112, they were both very kind and supportive people, and, like, especially my term project mentor, like, I think I talked to him once about, like, how I was doing in the class, because I, like, low-key bombed the second midterm, and I was really worried, and I really wanted to TA, but I was really worried that I wouldn't, like, get good enough grades to do that, and he was, like, very encouraging. Like, to him, it, like, wasn't even a question about whether I could do it, so I think that was, like, the big thing that, like, motivated me to, like, push through and, like, keep locking in. And then after that, I took 2 programming classes. I took, like, our data structures, algorithms intro class, and then I also took functional programming. And I always thought that math was sort of, like, doing pedantic bookkeeping about, like, numbers and primes and, like, maybe geometry shapes, but I realized that you can write proofs about a lot of things, and, like, the idea that you can prove the correctness of a program was, like, very interesting to me. So then after that, I was like, okay, like, discrete math is, like, kind of, like, things like that, things related to that, and I just kept on taking more classes, and then my sophomore spring, I declared my major in discrete math and logic, because I realized, like, that's something that I really liked, and, like, I could see myself pursuing it, and yeah, that's how I got there.
Yeah, that's wonderful. So I guess you kind of answered my other 2 questions. So to summarize, to summarize, like, I guess you kind of came into, like, CMU, like, before coming to CMU, like, all of your, like, goals were kind of motivated by, like, what you're getting approval from, like, people above you, whether it be, like, parents or just, like, adults, but then when you got to CMU, you're like, fuck, like, everything's hard, but then you found so much enjoyment in, like, programming, and then when you, like, moved on from the intro class, like, seeing how math and, like, logic, like, entered that space. Yeah, no, exactly. I think, like, I would have liked to think that, like, my, like, interests weren't motivated by what I got approval for, but really looking back on it, like, in high school, you don't really know what you like that much. It's kind of hard to know, especially in a culture that really prioritizes and privileges certain things, and I think, like, it really just took me, like, being bad at things to realize that, like, being good at things and getting approval is not what you should base your interests on, because, like, you can always get better at things, but you can't learn to love them. This is true. Could you talk about like what you're working on right now and like why are you doing it?
Yeah. So I think like I've discovered through my experience as an industry that like I really enjoy research, and like the area of research that I'm working in is like formalization and interactive theorem proving, and it's the idea of that is basically like, okay, if you write a math proof in English, someone can like read it and like check over it for you, but there's really no way to like verify for sure that it's correct. Whereas like there are formal languages that you can write math proofs in where like the way that the system works is like sort of like a type checker, like the way that like if you write code in like a functional programming language, or like if you like even like writing code in like C, like if your types are fucked up, like it'll get mad at you.
Right.
This like it's like a sort of similar idea for like checking correctness, like in like an interactive theorem prover, and like the work that I do is like formalizing math, like using an interactive theorem proving like proof assistant language called Lean. But I'm also interested in like a few other areas of like math research related things. Like I think, let me think. Oh, computability theory. Like you know that stuff we did in 251?
Yeah, so 15251, it's a class we took together.
We did.
Yeah, Arohee was really good at it. She really carried me. It was a theoretical computer science class. And can you explain what computability is for people who don't know?
Yeah, so I think like theory is really interesting because it like asks a lot of questions that like maybe like you have never thought of before, or like they're like big questions like what things can we compute? Like, what can we do? Are there problems that are inherently unsolvable? Or problems that are inherently unsolvable, like, in a certain amount of, like, time? Like, computability theory, like, tells, like, basically asks the question, like, what types of problems are decidable? Like, what can a computer actually do? And I think, like, computability theory is really interesting because, like, when we bring in this question of, like, what things are possible or not, like, it has a lot of very interesting implications with, like, philosophy.
Yes, this is true.
Yeah. Like, the intersection between math and philosophy is actually, like, a very expansive, very interesting field. And, like, I've been, like, getting really into that lately. But, like, I guess the idea is, like, do you remember, like, talking about Gödel's incompleteness theorems?
Yeah. Like, okay, I'm gonna be honest. I remember the name. If you asked me what is the incompleteness theorem, I could not tell you. But, like, if I was in a conversation with someone who wanted to prove how smart they were, I would drop Gödel's incompleteness theorem to make them feel bad about themselves.
Oh, yeah, good. And that's always a good strategy, you know?
Yeah.
Like, you, like, need to play the game.
Right. Play the game.
But the incompleteness theorem basically says that, like, it's not possible to prove, like, the correctness of a mathematical system using that mathematical system.
Oh,
and, like, the other part of it is that, like, in every mathematical system, there's always going to be a statement in that that's, like, not provably true or false.
Yes.
And, like, the idea, like, behind the philosophy of that is, like, if we have, like, if it's possible that, like, within, like, some sort of formal system, even if we, like, specify as rigorously as we can, there's always going to be something that we can't prove whether it's true. Like, that's, like, interesting, right? Like, a lot of philosophers have, like, taken that and drawn parallels to, like, whether God is real. Like, I think, like, there's, like, low-key beef between mathematicians and philosophers sometimes.
Hella funny.
Because, like, mathematicians think that philosophers, like, are doing it in an unrigorous way and aren't really interpreting it, like, with, like, the context and the specificity that it requires, and like philosophers think that mathematicians are like boring and pedantic. Low-key tea on both sides.
Yeah. This reminds me of this book I was reading. It was talking about, or it's called The Medium is the Massage. It's a play on The Medium is the Message, that kind of saying. And one thing they talked about, or like, there's this diagram that was in, like, our lecture slides, where it's, like, these circles, and it's, like, these are our truths, and then it's, like, this, like, web of, like, deduced new truths that are based off of, like, these, like, very basic axioms.
Yeah.
And in this book that I was reading, it was talking about, like, how when we learn the alphabet, like, ABCDs, like, when we were, like, a child, like, just using the alphabet and, like, words to communicate, that is already an abstraction, and, like, so much is already being lost. And what you're saying, like, oh, like, the building blocks we use in math are missing some things, which kind of goes on with, like, Gödel's incompleteness theorem. So that just reminded me of, like, that little book.
Wait, that's really interesting. Like, I think, like, thinking about knowledge as an axiomatic system and, like, deduction rules, like, I think, like, well, philosophy is very mathematically rigorous, actually. Yeah. Like, the way that a lot of people practice the study. And I didn't know that. But, like, I think, like, a very common misconception about math that, like, I feel like I hear a lot from just, like, random people that ask me what I study, and then I tell them I'm a math major, like, oh, wow, like, that must be so hard, I could never do that. Is that, like, it's, like, this fundamentally uncreative field that, like, is, like, has, like, very, like, strong lines between, like, what is true and what isn't, and you just, like, sit there and, like, work out problems. And, like, that's really not the case. Like, I think there's, like, very many ways to be creative with, like, structuring a proof, or, like, how you, like, describe and, like, present a mathematical argument. But I think there's also a lot of creativity to be had in, like, what arguments are being made, and, like, what things are being prioritized in, like, your own, like, research and, like, what you're studying. And I think that, like, the overlap between math and, like, so many other things, especially philosophy and, like, fields that are, like, less techy, like, I think really shows that, like, it's, like, a very esoteric, expansive, like, math is pretty gay. Like,
yeah,
you know?
math is really gay.
Math is gay.
Math is really gay. I feel like this, like, misconception that, like, math is, like, boring as hell and, like, uncreative, I feel like this largely stems from, like, how horribly it's taught in the United States.
No, exactly.
Yeah, because my discrete math professor in freshman year, she was from Eastern Europe. She showed us this really, really beautiful, like, math proof that was, like, it was proven by a picture. That's my favorite kind of proof by picture.
Oh, yeah.
Yeah, because I think math drawings are very beautiful, and it's easier to parse through than with, like, linear string of words, I guess.
Yeah.
But this proof was so beautiful, and she was like, yeah, I learned this when I was 14, and since then it's just been burned in my mind. And I was like, wow, I'm 18 years old. Like, at the time I was 18 years old, like, I was curious, like, if I had learned this, like, earlier on in my life, then I wouldn't have, like, despised math so much, because, like, before taking this discrete math class, I was like, oh my god, math is boring, like, I'm just doing it because everyone else in the Silicon Valley is taking calculus.
Yeah.
Yeah.
No, I really felt the same way. Like, I think when I was, like, growing up, like, I was always very bad at, like, bookkeeping. Like, I would, like, drop negative signs and drop coefficients and, like, make, like, what people call careless errors. I don't think that's really a good term for it. And, like, at the time, I didn't know that's because I had ADHD. Now I do. But, like, I think, like, a lot of the adults in my life always just said that I was very, like, not locked in like that, and, like, not self-disciplined, and, like, I just didn't really care. And I think that sort of led me to believe that, like, math couldn't be something that I would be good at, because I thought that, like, being good at math, like, means that you must be really rigorous and, like, really formalized with the way that you, like, conduct computation. But, like, being a good calculator and being a good mathematician are two entirely different things. And I think I really only started to realize that, like, you know, once I got to college, and I realized that there's, like, a lot more to it than, like, doing the power rule and the chain rule and integrating by parts and not dropping a sign somewhere.
Oh my gosh. Yeah. Yeah. So I guess to summarize this section, math is gay as hell.
Yeah.
And calculus is...
Kind of straight.
Yeah, calculus is
a
straight.
little bit homophobic.
Calculus, I think it's very homophobic.
No, I agree.
Yeah, because it's so complete and it's, like, done. It's like a dead horse. you beat the dead horse more by doing more computation and dropping signs and making your little cheat sheet for Calc BC, the Taylor series.
Oh, yeah.
McDonald's. Taylor series McDonald's.
Well, of course. Okay.
Yeah.
So we actually met through TAing. I think we mentioned this.
Yeah. No, we didn't.
Did we?
We did not. We have not talked about that yet. Yes.
Do you want to explain 112?
Yes, I'm happy to explain it. So, 15112 is the Intro to Programming course at CMU. If you take APCS and you score a 5, you can waive it. There are a lot of, like, equivalent courses. I've talked about this in one of my other videos, but 61A at Berkeley is, like, the equivalent of 15112 for all my California baddies. Basically, it's like the intro to coding course for people who have no experience coding, and they usually teach it in Python, and they cover, like, how to write functions, for loops, while loops, and, like, basic data structures like sets, dictionaries, lists, etc. We make the students write Tetris, and it's like a sprint. I feel like it really is a sprint, but it's really cool. Yeah, so that's what 15112 is, and we both TA'd it, and that's how we really got close. Yeah.
Well, that and 251.
Oh yeah, well, that's how we met. And then 251 brought us even closer.
This is true.
Yes.
Never underestimate the power of discrete math to bring friends together.
Yeah. like, what do you think were your biggest takeaways from, like, teaching? Because, like, I don't know, it's really interesting being in, like, a higher position of power than, like, a student.
Yeah, I think, like, when I was a student, like, I think I mentioned this, my TAs were both, like, very supportive and kind people, and it was, like, really because my 112 TA, like, encouraged me to apply to TA that I, like, was able to do it, like, to begin with. Like, I don't think I really would have had, like, the balls to do it otherwise. I think, like, I was, like, a very, like, I wasn't the most confident in my abilities at that point in my life, and I think just, like, having, like, someone, a mentor figure who believed in me and who was, like, kind and who was understanding, like, was really, like, the thing that I needed to, like, be successful, and, like, I think that if, like, that hadn't happened, like, I think the whole course of my undergraduate career would have been very different. So, I think, like, as a teacher, like, I really always tried to keep that in mind, that, like, the way that, like, I interacted with students and, like, how I provided encouragement was really important, because, like, I just think of myself as, like, some, like, random person, like, sure, I know programming, I can teach it, like, I can talk to people and, like, give them advice maybe, but, like, I'm just, like, another student. But, like, a lot of these students, especially younger students, like, really see their TAs as, like, these, like, mentor figures, people to look up to. And I think, like, I always try to really try to meet people where they're at and, like, give people the encouragement that, like, I thought that they needed. And I think I noticed, like, in my time TAing that, like, just, like, approaching things, like, kindly and openly and, like, you know, assuming benefit of the doubt and just, like, trying to be, like, a compassionate educator, like, really led students to doing better and, like, having a better experience.
Well, yeah, I totally agree, because, like, I feel like before I took 112, like, I had this idea in my mind that, like, computer science is full of, like, I don't want to say it, but, like, nerdy sweats. Nerdy sweats of a certain demographic. Redacted.
Yes.
Redacted demographic. Seeing these TAs who are across, like, so many majors, like, I think 15112 does a really good job of, like, hiring, like, a really diverse staff of, like, different, like, majors, and just seeing that, like, they were all able to succeed, I feel like that sets a really good example. And also, like, it's really important to keep in mind that, like, this is a lot of people's first entry point to the world of computer science, and, like, there's so much, like, beauty in it, and we don't want to, like, cock block them and make it look bad, like the way the U.S. calculus apparatus math,
the calculus industrial complex.
Yes, the calculus. We don't want that. We don't want the calculus. That's so funny. We don't want to replicate the calculus industrial complex, but we want to, like, create a very welcoming environment into the world of computer science, because there are some bad parts, and I feel like that really gets inflated in popular culture, like bad parts of computer science, but there are a lot of good parts as well. So, like, I don't know, in positions of power, it's kind of like our responsibility to, like, expose that to people for the first time. Yeah, I
really agree. A lot of people, I think, especially, like, when I started doing it, programming for the first time, like, I really just didn't think that it was for me. Like, I think that there is societal messaging around, like, who can and can't, and, like, who is and isn't suited for it. And, like, I never thought I was good at math either, like, when I was a kid, so I really thought that I just, like, didn't have that dog in me to do logic like that. But I think that just, like, being there and, like, being able to do it and, like, having, like, you know, seeing other queer people, like, be my TAs, that really, like, helped me to realize that, like, this thing can be for me too. And I think that, like, that's why, like, one of the reasons why, like, diversity in CS academia is so important, because, like, I think there's a lot of societal messaging around, like, what the field is and who can do it, and I don't think that that's, like, the full story at all. So just like people with different perspectives, people who are systems critical, maybe, like, people who don't necessarily fit, like, the stereotypes, people who don't necessarily want to go into industry, you know, like, just having, like, a diversity in opinion and thought really helps, like, make the field seem like a more expansive and accessible place for people that might not necessarily be the type to be drawn to it right away and then go be a software engineer. Yes.
You can study computer science and not become a software engineer.
This is true.
Yes. I think this is a good segue into our next topic, talking about startup versus big tech.
Oh, yeah. So I did 2 internships, like, while I was in undergrad. Well, 2 industry ones. My sophomore summer, I worked at a startup. It was, like, a system startup that made, like, parallel hardware for, like, data center processing. and like just like fast computation. And then my junior summer, I worked for a big tech company.
Redacted
Big tech company. That like, well, they do a lot of things. The department that I worked in was like relating like again to like ML hardware. I'm not really sure exactly how I ended up in there, but like yeah, the work that I did at my sophomore summer internship was, I think, a lot more interesting. My mentor at my internship was like one of the people who like served on the committee that created the IEEE 754 floating point standard, which is basically just like all the rules for how we do floating point math in the computer, like everywhere.
Whoa,
yeah.
I've never learned that, and I hope I never learn that.
Wait, because I think people think it's like very like pedantic and like terrible, but it's actually really interesting.
Really?
I really enjoyed it.
Why did they take it out of 213 then?
Because it's useless.
Oh, okay.
Like, there's like a very small subset of the population that actually like does this stuff or is interested in it, because like good algorithms that do math like already sort of exist. Mm-hmm. So like hiring like a research mathematician to develop a better floating point algorithm is generally just like not like a good return on investment for companies.
I see.
I don't think it's like a really huge research area either. But like there's classes at CMU that like teach this stuff, like numerical methods. I think that's what it teaches. Never took it, but yeah. This is a thing that some people do esoterically. But I thought the work was really interesting. Like what I did was like I built like an API to like test like speed and accuracy of like floating point, like various floating point functions, like on like the company that I work for, like their hardware versus like other competitors, and it was very interesting work. Like I think like I got to learn a lot about like the way that math was done in the computer. I learned a lot about floating point error and how it happens, overflow, underflow. I think it made me like a lot more a lot more precise as a mathematician too, and like better at writing test cases and better at programming. So I think the work there was quite interesting. I didn't really love the culture. Like I was the only girl.
That's how it goes sometimes.
Yeah. And like I think one of the only queer people too. And like I think like as I'm sure like you can imagine, like that led to a lot of uncomfortable experiences, like being discriminated against in the workplace and just like microaggressions and like low-key macroaggressions sometimes too. And I think that like my junior summer I was like, okay, like I might enjoy software engineering sometimes. Well, the work that I was doing wasn't really engineering. It was like pretty mathy. So I'm not really sure like why that led me to draw that conclusion. But I think I really wanted to. I wanted to like it because it's a stable career and like you can make money and it's socially respected. I was like, like, I just really wish that like this thing could work out so I could just have like a stable life and like know where I wanted to go. Like I really feared the uncertainty. But my junior summer I worked at a redacted big tech company. And I was like really, really hoping that I'd enjoy that experience because like also it's a bigger place. Like I thought there would be like more people that I could connect with, maybe more people with like my lived experience and like my views on things. And I think that part was true. Like you work at a big enough place, like you're gonna meet people who think more closely to you. But I realized in that internship that software engineering really is not for me. I think one of the issues with a lot of these companies is that people just don't really like it there.
Yeah.
And I think when you go to work every day and, like, you don't really like your job like that and, like, no one around you really likes their job like that, and if they say that they do, they're probably lying. Like, that's not, like... It's not, like, the most wonderful feeling in the world. And I think, like, having, like, honest conversations with people at this company, like, a lot of the full-time engineers were there, like, for financial reasons. And, like, I think it's reasonable under capitalism to, like, want to have a stable career that pays well. But at a certain point, like, if you hate your job and every day you go to work, like, you just low-key don't want to be there, like, I guess it's up to every individual person, like, what they, like, want to prioritize in, like, their career. But to me, that just didn't really feel worth it. And I didn't really feel like I fit in very well there either. Like, I think, like, people can be very, like, conformist in the office, and, like, there's definitely, like, office politics, especially, like, in, like, larger companies. I think there's expectations to say, do and present yourselves in certain ways. And I think also, like, because, like, so much tech, there's, like, ethical gray areas, I think.
Yes. Yes. There are, especially at this redacted company.
Yeah, at this redacted company. Part of this redacted company had contracts with, like, various government institutions to do forms of database policing, which, like, I think ethically is not very great. And I think like the way that a lot of engineers like cope with like the fact that like the work that they're doing doesn't necessarily align with their morals and their values is to just like be very depoliticized about it. Like, I'm just creating a product. If they're going to use my flight tracker to track missiles, like, I'm just creating a flight tracker. Whereas like that's not, like, I think there's a gray area there, because like I can understand like why people might not necessarily want to engage with these things, especially since like so much, like such an expansive sector of like the industry is like kind of like this. But like at the same time, like I think it's very important to be aware of like the impacts of your actions and the privilege that you have, especially because like right now tech is like such like an expanding field, and like I think the gap between people that know how it works and people that can influence it and like people that it affects is widening more and more. And like I think like as people that like understand these things and like have tech literacy, especially with AI and stuff, I think there's a lot of like dooming and glooming about it.
Oh yes, yes. That is true.
And like I think like a lot of the critiques like about AI come from people who don't necessarily understand like the technical like basis of how it works, and I think it can end up just like being very like toothless and like very non-specific. And like I think saying stuff like AI is evil because it uses too much energy when they're like actually talking about training large language models kind of takes away the language to like talk about some of the other problems, like data bias and algorithmic bias and like these predictive policing softwares, which is also a really big problem. But I think like the people that are critiquing it the most are not necessarily the people that are the best equipped to talk about it, and the people that are very well equipped to talk about it are not necessarily people that disagree with it from a moral standpoint, or at least are willing to say that. So like I think like it's very important that like people talk about this stuff more, and like because like we know how it works, like I feel like we really have privilege here over like general society, because like most people don't understand how AI works, but we're all affected by it.
We are like driving at like full speed into like disaster. Like I feel like that alleviates like my stress a little bit, where it's like it's not my fault that I can't get a job. Like the people up there are just doing a really bad job of running the planet.
It's not you, it's late stage capitalism.
Exactly. All right, I think that was a good ending. Yeah.